Hello everyone, my name is Nitesh Paurel, roll number 19NS0128. First and foremost, I would like to thank Namchi Government College, Department of Physics, Sikkim University for providing this platform, and my teacher CP sir for helping and guiding us. My topic is van der Waals equation. It is also known as real gas equation. There is one equation known as PV is equals to nRT, which is called ideal gas equation. In this equation, ideal gas equation, there are some false assumption such as for volume and for pressure. For volume occupied by the gas molecule is neglected as compared to total volume of gas. Means, suppose this be volume, then the volume of the gas will be neglected as compared to the volume of this. But in real gas, volume also have some values, or volume is also there. So to erase this error, suppose we press the pistol, then for a point, suppose this is called co-volume. What is this co-volume means? For example, suppose this is a syringe or injection. Suppose we cover their base and try to apply pressure on the pistol, then they will move to a certain point from which the pistol will not move further. That volume is known as co-volume. And there is a factor called B, which is actual volume occupied by 1 mole of gas. Therefore, so this will be B minus B is the actual volume of 1 mole of gas. Therefore, NB, N is the number of mole. This is volume correction. Now second one is pressure correction. What ideal gas says that there is no force of attraction between the molecule, means there will be no force of attraction. They will, suppose there are molecules, then there will be no force of attraction, or they will not exert force on the wall of the container for ideal gas. But in real gas, there are some force exerted by the molecules on the wall of the container. So for that, it will be proportional to, pressure will be proportional to number of mole per unit volume. Means here are many molecules, so they will exert some force on the wall of the container. So this will be number of mole per unit volume, and there will be some force between these molecules. Suppose there is this molecule and there will be some molecule around it, so there will be some force of attraction between these all molecules, so that will also be number of mole per unit volume. So this will be n square by b square, so this will be equals to a n square by b square, where A is major intermolecular attraction. So therefore it will be P plus measured pressure plus this correction factor, this. Therefore from this and this, first and second, we find that P plus a n square by b square, b minus nb is equals to nRT, for which P is the measured volume pressure, this is the correction factor of account for intermolecular forces, this is that, and this is the measured volume, and this is the correction factor of to account for molecular size, and this V is also directly proportional to the size of molecule. Now there is a compressibility factor denoted by Z, which is equals to PB by nRT, and for ideal gas, this is equals to 1, means for PB is equals to nRT, it is ideal gas, it will be Z is equals to 1. But for real gas, Z is not equals to 1. If Z is greater than 1, then real gas will show positive deviation, and if Z is smaller than 1, then it will show negative deviation from ideal behavior. Let's say will show this positive. If Z is greater than 1, then it will show positive, and if Z is less than 1, it will show negative deviation. So now unit of A, what will be the unit of A? Unit of A will be atom liter square mole inverse, and for B unit will be liter mole inverse. You can find out from here, because A we are finding this, so volume will be, suppose this will be, A will be a n square by b square is equals to P, so A will be P b square by n square, therefore P will be at volume will be this, and number of mole will be mole inverse. Like that, V will be also equals to N, V will be equals to V. So V is equals to V by N, therefore it will be the mole inverse. So this is the way to find the unit as a unit of A and B. Now we know this is Van der Waals equation. Now some cause or factor, compressibility factor of Van der Waals equation. Now we will do that. So first, at high pressure, what will be at high pressure? We know that P plus A by V square, V by B is equals to RT. This is for 1 mole. This is for N is equals to 1 mole. Therefore, A by B square can be neglected in comparison to P, because the value will be smaller as compared to this. Therefore, let's neglect that. So this will be P minus B is equals to RT. So PB minus PB is equals to RT. PB is equals to RT plus PB. Now we know that Z is equals to PB by RT. Therefore from here, dividing by this equation by RT, we find that Z is equals to 1 plus PB by RT, which is greater than 1, which means that at high pressure it shows, if Z is greater than 1, then it will show positive deviation. So it will have positive deviation. So at now low pressure, now at low pressure, P plus A by B square, B minus B is equals to RT. Now from here also I can neglect B as compared to B, because this value will be much greater than this. Therefore P plus A by B square, B is equals to RT. Therefore further it will be PB plus A by B is equals to RT. So PB is equals to RT minus A by B. Therefore Z will be equals to PB by RT is equals to 1 minus A by B RT, which is less than 1, because you are subtracting something with 1 means you will get the value lesser than 1. Therefore if it is lesser than 1, it will show negative deviation, and this will show positive deviation. Now at very low pressure, what will be? So we'll find out. P plus A by B square, B minus B is equals to RT. at low pressure what will happen is V will be greater, large, so great that it can neglect both this as well as this. So this will be PV is equals to RT. Now Z will be here PV by RT, which is equals to 1. So if we draw a graph Z versus P, then this is 1 because ideal gas has Z is equals to 1 for ideal gas. So we find that at high pressure Z will show positive deviation and at low pressure Z will show negative deviation. So therefore graph will be some like this. Suppose this be N2, then this will depend upon this gap between Z and that will be depend upon intermolecular attraction. So if this, suppose this is O2, because why O2 has more slope as compared to N2, why it has more deviation, you will say that this has more intermolecular attraction than compared to this. Therefore this will show this graph as P and B. If we look the graph P and B, as we know that in ideal gas, if we draw PB, then this will ideal gas will show this deviation. So this one is for Z and P. Now this is, I say that this is 1, this will be ideal gas. Now important notes about the van der Waals, that is real gases shows ideal gas behavior when pressure and temperature is such that intermolecular force are neglected. Real gas show ideal gas behavior when the pressure approach 0. At low pressure all gas have J is equals to 1. I solved that at very low pressure Z will be 1, and gas shows ideal gas behavior when volume occupied is so large that volume occupied by the molecule can be neglected when pressure is low. And at pressure is low, I just said that. And real gas shows ideal gas behavior at low pressure and high temperature. Means real gas will also show ideal gas behavior when at low pressure. What will happen in low pressure and high temperature? Real gas shows ideal gas behavior when it has low pressure and high temperature. Therefore I like to solve some questions that I have done. So I like to show that a real gas obey van der Waals equation will resemble ideal gas if the real gas obey van der Waals equation will resemble ideal gas if the first one constant A and B are small, A is large and B is small, and A is small and B is large. Constant A and B are large. So we know that P plus A by B square, B minus B is equals to RT. It is for 1 mole. As there is no NB, nRT, that means it is for 1 mole. So what will happen, that A and B are small, then A by B square and B would be small, and the gas will resemble ideal gas. So A is correct. Therefore, I would like to revise again for your better understanding. I already mentioned that ideal gas equation have some false assumption, that is about pressure and volume. What they said, that there is no force of attraction between molecules, but in real case it does not obey that, because there are some force of attraction between molecules. They try to bind with each other, they will try to push each other. So this assumption is been corrected by this, because they exert some pressure on the wall as well as to the molecule closer to them. Therefore pressure correction for this will be this. And what they say in ideal gas is that volume is negligible as compared to the total volume, but there are some volume. That means they say that ideal gas can reach the volume up to 0, means they can, if they push the pistol, they can reach up to the air. But it is not true. As I give the example of syringe, you can apply that, you will see what will be the answer, that the pistol cannot be moved further. So therefore this correction is this. So substituting this on this, we will find this. So if for 1 mole, what will happen, this will be 1 and this will be 1, therefore this will be also 1. So this will be simply P plus N square by B square, B minus B is equals to RT. This is van der Waals for 1 mole of gas molecules, and there is a compressible factor which is called Z is equals to PB by nRT. And for ideal gas, PB, Z is always 1, and for real gas, Z will not be 1. If Z is 1, then it is ideal gas. If you were given a question to find is it to ideal gas or not, then you have to find the compressibility factor, so that if you find that Z is 1, then it is ideal gas, and if you find less than that, then less or greater than 1, it is real gas. So that's all. Thank you.